It's this balance, Rob, between the economy and the environment and energy. That waltz of the three E's, I've talked about that for decades now. And that overlap space I call the radical middle. It's radically lonely sometimes, but it's where the big challenges are. Hey, I'm Scott Tinker. I'm a geologist. I'm a professor at UT Austin and run a big research unit called the Bureau of Economic Geology. But in my night job, I started something called the Switch Energy Alliance, and we make films.
Scott, how does the state geologist of Texas end up making movies about energy in the developing world and getting involved in energy education in far-flung places? What's going on?
Well, I came down to UT 21 years ago to do this role, the state geologist and professor stuff. And I had been in the energy industry actually prior to that for almost 2 decades. And so I've always been involved with energy, Rob, a lot of speaking around the world, et cetera. But it became pretty apparent to me as our kids got older that film was the way that people are communicating now. And I met a guy named Harry Lynch, who's a great filmmaker, documentary filmmaker. He was interviewing me for a different film he was doing, and he asked me afterwards if I ever want to make a film together. I said, yeah, sure. How much will that cost? He said, well, to do a good one will cost this much. Well, this was 2009, 8, actually, right before the Great Recession. I said, oh, I can raise that. And then this recession hit. But, we pulled it off. And we filmed Switch, went to 11 countries and a lot of 50 different interviews and 20 site visits, and made a pretty wonderful film, I think, of wonderful fun on energy called Switch. And that's how it happened. That was a decade ago. So we've been doing that ever since, getting around filming in different locations and different subjects, different people, and really find it to be a fascinating way to see the world. But we agreed that we would be nonpartisan as much as possible, and we bring different political viewpoints to try to balance ourselves, objective. And then our goal was not to make anyone look bad, which is kind of different for documentaries these days. There's always a villain in every documentary, it seems, as the filmmaker tries to tell you what they want you to think. And we decided to make a different kind of film.
Yeah, I have to say, it's really noticeable in both films, Switch and Switch On, the more recent one, that you're very non-judgmental in situations where it would be so easy to be judgmental.
It's an interesting word, non-judgmental. I've been really lucky, Rob. I've been in about 65 countries, and I think travel like that improves tolerance, at least for me, of difference, right? It's opened up my mind, and we all have our biases, but to the whole different perspectives on way people live. Their societies, their governments, their religious backgrounds, educational. It's just so diverse and broad that I try my best not to have a whole lot of judgment when I'm visiting with people. I have opinions, of course, we all do, but I try to learn, because I'm learning all the time as we're out there. We don't write these films ahead of time. We actually have an outline, but we film and learn, and then we put in post-production, we begin to evolve a story.
How did you decide where to go and who to see and what that story might become?
Yeah, Harry's the brains. I'm just the pretty face. So, in what's called pre-production, we think about it. We think about the important components of a story on energy, for example. And that wasn't so hard because we wanted to feature each form of energy in its best light. Where's the sun great? Well, let's go to Spain. Where's the great wind? Let's go to Denmark. How about geothermal? We'll go to Iceland, nuclear, France, etc. And then we looked at energy demand in India, of course. There's a lot of demand and it's growing. So that one was a little clearer in terms of just where we would start. The film on energy poverty was a bit different. We really had to think hard about what kinds of energy poverty, and you're in this and you understand these things very well, but we ended up focusing in on 3 big areas. One is kind of that last mile, off the grid, if you will, rural. What does it take to get any kind of energy out there? And then one was under the grid. There's electricity all around, but you can't afford it, or you can't get the wires in, or they're illegal, or whatever. People are stealing it. So the big slums in the urban centers now. And then the third one was the whole area of cooking. and it sounds so trivial, but it affects a third of the population of the world today, is an inability to cook with cleaner modern fuels. So those were the three areas, and from that, we wanted to then look at kind of a couple different perspectives, at least, on each part of that story. So that led us to the countries.
And you just start walking around. I remember you told me how many hours you had for Switch On, hundreds and hundreds of hours of film and unscripted. But it looks very put together, when you see the film.
Yeah, again, in each country, we have what's called a fixer. It's a person that knows people, knows a lot of folks, and can help you get access to facilities, to people, to sites and other kinds of things, and help work your way through the whole bureaucracy of places and keep you safe. Some places are safer than others. So I don't mean to say it's just uncoordinated. I'm not walking around with my little iPhone, but so we know where we're going. We know who we're going to see. Now, here's a piece that you may find interesting. Harry actually won't tell me where we're going the morning of.
Oh, really?
And I don't know quite often. In fact, almost always, I don't know who I'm going to see or where. I might know we're going to the Grand Ethiopian Renaissance Dam. Of course, you have to fly out there, but I don't know what we're going to do, because he wants that first impression on the film to be a real impression. He wants to see me go, "What? Are you kidding?" Or things where I'm surprised. Because even though I might be able to ham it up a little bit, the most genuine is usually the first time you hear something. So we bounce back and forth. And as a researcher, it just kills me. I want to know all about these things.
But it's noticeable. And there are a couple of moments in the film where I think it shows that you're surprised, and you don't edit that out. I mean, there's like this woman in Vietnam you're talking to about coal plants.
Yeah.
And it just sort of left me chuckling.
Yeah. Well, I hadn't heard. I kind of knew, but I hadn't heard their Vietnam plans to build 40 or 50 new 400 megawatt coal power plants in the next 20 years. And the world's trying to push away from coal. And here we are adding 50 more. And that's just a drop in the bucket in Asia, really.
Yeah.
So, I'm like, oh, wow. And then you start thinking about optionality and well, okay, what else could they do? And we think about natural gas and bringing in LNG. Well, that's a port too, and doable, or nuclear, but it's the ring of fire. I'm a geologist, there are earthquakes and tsunamis and things.
Yeah. So these are the really, really difficult challenges in this entire part of the world. They have these available technologies. They work, but they're very, very dirty, for one thing, and they have terrible local effects. And of course, they put them on a trajectory to become enormous emitters of CO2. If not now, then in the certainly during this century, all of which somehow has to be reversed. When I travel around in these places, I get stressed because I want to know what the answer is, what I should tell them, what's feasible. And it's not always apparent.
Right. In fact, interesting you bring that up. I just spent the last week, literally a week, some all-nighters almost, tearing apart a massive global energy data set. Just the digits, not what people write about it, but tearing it apart myself with this question. How much CO2 could we reduce if we were to replace coal in Asia with natural gas at the same gas to coal ratio as the US today? Because we've done that in the United States. We've gone from a 5x to a 0.6x now, it turns out, gas to coal. Not just talking power sector, talking all coal, all natural gas. So I wanted, and this wasn't an easy question to address. And so I've been powering through that, just wrapped it up late last night, looking at how much coal is being used in Asia, China and all of Asia, including Australasia. And then what would it take in exajoules to replace that with natural gas? And how much would CO2 would the natural gas emit? And then what's the net of that? And then what if you were going to do it with solar and wind, what would that take? Or with nuclear or some mix? And they're big numbers.
Yeah.
You'd be cutting out about 70 to 75%-ish of coal and replacing it with natural gas to get to a 0.6 ratio. Right now, China is just over 11x coal to gas, 11x, and we're 0.6.
Yeah.
And the rest of Asia is around a 3 to 4x coal to gas. So these are massive numbers. And it turns out it's about 2.8 gigatons, 2.8 billion tons per year that emissions would be reduced by just going to a U.S. ratio. And it approaches 7 gigatons if you capture and store the CO2 from the natural gas and or use some mix of nuclear and renewables.
This is out of a total of 40-odd gigatons.
Well, about 35 energy gigatons, 35 to 40, and that's not all the ag. People ignore the ag. Ag does a lot, but energy. So yeah, it's anywhere from 7 to 20% or more of total human or anthropogenic emissions just from that Asia switch. And this is actually doable at scale. It's a challenge of getting certain folks to acknowledge that maybe methane or natural gas has a role to play. There are those who still think it has, it's a fossil fuel and so it's terrible. But I'm not in that camp.
I've had conversations in some countries about CCS, particularly in India, where of course they had that horrible experience of Bhopal. And there's the real reluctance to putting stuff into the ground that might come back out again and do a lot of damage and injure a lot of people. And so CCS, unfortunately, has sort of fallen into that. And there's reluctance to do it. They also don't have the same geology as us. And it's not so easy to put CO2 into the saline aquifers, for example, I'm sure. But they do have basalt and the possibility of mineralizing CO2. And it's a conversation that I tried to have with the then Minister of Power, Piyush Goyal, and he didn't really want to have it. But it was just a really important reminder of how not all options are on the table everywhere.
Right.
Even these mitigative options.
Absolutely. No, that's absolutely true. And full disclosure, I've had a pretty large team of CCS folks for 2 decades now. And in fact, when Ernie Moniz became secretary, in the first few weeks, I brought some of the team to DC and talked to him about offshore CCS. And Ernie really liked it. And that kicked off his 4 years. And it's continued the last 4 years of looking globally at offshore CCS. A lot of advantages there, a single owner, a government, infrastructure that you can put on the ocean floor, sources right there, petrochemicals and refineries and power plants and hydrogen plants and cement plants, et cetera, sources of CO2 right there. And then on passive margins, or not active plate boundaries, but passive ones, big sediment piles. And so the brines will hold a lot of CO2. And that's really where we're headed, I think. And India has that offshore capacity that I think is very real at scale. So as we begin to think about hundreds of millions to billions of tons of carbon dioxide each year, these 35 to 40 gigatons we were just talking about, it's going to take something like that. But I think it's a wedge. It's part of that wedge for sure.
It's an interesting idea. I mean, we're constantly talking about options for developing countries to both develop their electricity sectors, their energy sectors, and decarbonize. And I haven't really thought a lot about offshore sediment sequestration of CO2. Tell us a little bit more about that and how it works, because I don't think people widely appreciate the scale at which CO2 could be sequestered if we went down that path.
Yeah. I mean, of course, there aren't many facilities in the world that are doing this at scale right now, but one of the big ones is in the North Sea, Norway, and they've been putting CO2 down for many years now. So there's a model, and that's a pretty challenging environment.
Yeah.
The Gulf of Mexico and Texas is a little simpler, occasional hurricane, but every place has something. But what you have is a big stack of sediment, usually sands and muds, shales, that are not that compacted. So they have a lot of pore space in them. And it's full of water, salt water. Now and then you find oil and gas, but mostly it's salt water. So you actually can put CO2 at pressure. It's called a supercritical phase. It behaves almost like a liquid, and you put it down into the ground, and it goes into the brine. and it's trapped there. It dissolves and or is trapped in its phase and stored. And it carbonates that salt water a little bit, about less than your Coca-Cola, So really, it's not that fizzy. And unless you change that phase by either shaking it a lot or opening it up, which is the things you would protect against doing, it'll stay there for a very long time, as long as needed, really, to help mitigate some of the emissions for climate change. There are a lot of opportunities for this around the world today. Over like 50 to 100 gigatons of storage in oil fields offshore, and then those brines which go way up from there. And to give you a feel for that, West Texas has done a lot of enhanced oil recovery, which uses carbon dioxide or CO2. It just improves the way the rock and the oil interact. It makes the oil move easier, releases it from the rock. So, but that all of the EOR out there in West Texas is not even 1 gigaton over the last 50 years. So we're talking about 50 gigatons of EOR and hundreds of brine. These are big numbers. And it's going to take that because, as we were just discussing, Asia is still building remarkable amounts of new coal power plants.
Have you found yourself in conversation with any of the people who are doing that, or the leadership of the countries who are involved in building up their coal infrastructure about sequestration? Or, I mean, it's hard to get these guys to even put scrubbers on their coal plants. Oftentimes, the idea of building infrastructure to start sequestering under ocean sediments.
They'll put scrubbers on; they just won't use them.
And then that's a cost issue.
Yeah, it keeps it cheaper if you don't turn on that nasty, particulate scrubber and the ash and the SOx and the NOx and mercury. So they bolt these things on, but quite often they don't turn them on because it keeps the electricity price lower.
It's such a good indication of the extreme cost pressure that one's operating in that environment. And when you start talking about, gee, you should really have lithium-ion batteries in your grid. And you quickly start to sound like an idiot. And yet these are the options. And so you have to have the conversations.
Yeah. So I have had conversations like that in many places. And I think you end up starting to get in conversations about what we were just talking about. It's this balance, Rob, between the economy and the environment and energy. That waltz of the 3 E's. I've talked about that for decades now. And that overlap space I call the radical middle. It's radically lonely sometimes, but it's where the big challenges are. So you have to begin to get in there with data and compromise and be wrong, willing to be wrong, but looking at solutions that would maximize or optimize on the energy and the economy and the environment so that you get the right energy underpinning a growing and healthy economy, which can then invest in the environment and that virtuous waltz. Because without that, again, those countries I've been in, the dirtiest environments on the planet are where it's poor. They just can't afford to clean up the water and the soils and the local air. It's terrible. And I'm not even talking about atmospheric emissions, just the other pillars of the environment, land and water and air, which are still important to humans, by the way. Even though it seems like we only have one thought in our brains these days, climate change. But
in the fancy part of the world. I mean, it's interesting when you're in a country like India, for example, or Indonesia, and it becomes very apparent that there is no escape in wealth for people who are living in these countries where they're not attempting to control pollution. And you come into them thinking about other stuff, maybe climate change and fancy things like sequestration. But I think that people in wealthy countries are somewhat insulated from climate change as an immediate concern. But when you're in these countries, the poor and the wealthy all experience pollution desperately in some cases. I mean, Delhi is worse than Beijing, oftentimes now, especially in the season that we're now going into.
Yes.
And that seems to be driving a lot of policy.
Well, and it should, because the health impact numbers are staggering. We show in our film Switch On that 3 million people a year are dying just from breathing indoor smoke in their homes from cooking with biomass of various kinds, wood and dung and coal. And 3 million people, that's 2 times more than have died from COVID this year. every single year just from breathing smoke, and then cataracts and cancers of various kinds, pneumonia in the kids. It's awful.
And just a noticeably lower quality of life, no matter how rich you are.
Yes, completely. I think that's the right thing to focus on if you only have so much capacity, is the local environment and health of your citizenry. So the question then becomes, how do you increase the capacity, right? The economic capacity such that they could then add to it the ability to turn on the scrubbers on the coal power plants that we just talked about and add a little costly electricity and maybe even bolt on a capture unit for CO2 and begin to sequester that. And by the way, every form of energy has these challenges. If I'm capturing the renewable sun and the wind, I'm doing it with non-renewable stuff. Turbines and panels and the batteries to back them up are all non-renewable. And it takes a massive amount of resources to construct those panels and turbines and especially those batteries to capture the sun and the wind. And as a geoscientist, I like mining. I don't mind mining, but most people I talk to don't think mining is green. And they don't think battery manufacturing plants, chemical plants, are green. And they sure don't think landfill disposal of chemical things like batteries is very green. And so when we go through that little loop and I ask them, well, why they like EVs, they say, well, it's for the climate. I said, yeah, but how about, is it green? Mining, manufacturing, disposal, and landfill, chemical stuff, is it green? Oh, no. And then they don't like me because it's not an on or off switch. We have green cars and dirty cars. No, we really don't. It's just a different impact on the environment, and it will be a very large one. So I think that's the great challenge is in the radical middle is finding solutions that maximize energy, secure energy, maximize the economic benefit, minimize environmental impacts. As we've been talking, it's going to vary around the world. There's no single solution. India will have a different set of resource options and government options, et cetera, than do China, than does South America, North America, the Middle East, et cetera. These different regions are going to handle this differently, and that's a good thing.
So we're coming at this from the perspective of university people. And university people have traveled around and looked at these things and met people in countries that have to go through these transitions, and they're much more difficult than our transition because they're trying to economically develop at the same time very aggressively. And they have a lot less capacity, a lot less flexibility in what they do because of that. And so my sense is that they need help and guidance, but it's not clear where that guidance comes from. Who is it? Who's that dispassionate third party who can sit down with the leadership of the government of India, for example, and say, these really are the objectively best options. This is an objectively right plan for you to follow. And I've been sort of thinking about how universities could play a much bigger role in that.
I'll throw an idea out here for the first time. So,
okay.
Never actually written or said anything about this, but we always have new possibilities. John Kerry's coming back in as the climate leader in the country, and he and Ernie knew each other well. They went to spend some time in Iran together, et cetera. Just as we have an international panel on climate change, I'm wondering if we should have an international panel on energy solutions.
I think it's a great idea.
IPES, and really bring together the global leaders on energy solutions, because those don't always align with the politics of climate change. We know that, on one side or the other. There's kind of the drill baby drill way out there, and candidly, there's the Green New Deal way out there, and neither one of those are practical or actually solvable. But I think there are energy solutions, and it would be really neat to have an IPES, and I'd love to think about how to do that and be part of something like that. And it's very much needed today. And then you get objective academics, and you bring together industry leaders and government leaders, because it all has to play. They have to play together, or they won't be implemented.
My nighttime hobby is to be the president of the International Conservation Fund. which is actually an offshoot of the International Conservation Fund of Canada, which is a remarkable organization. And it's concerned with preserving ecosystems in developing countries, as well as in developed countries. But there are so few protectors in developing countries, and they're often, the ecosystems are under so much more pressure in many situations. That's where our focus is. But I think I may also sound heretical in saying that that's a higher concern fee, and it's one of several than climate at the moment. In part because I know that other people are going to help with climate. We have a lot of momentum and engagement. We need more. We need to do the things that we were talking about in developing countries, but there are other challenges that people face now: their health, their environment, their standard of living, that in many ways gets in the way of a rapid climate transformation, and have to be solved either first or at least at the same time.
Correct. And again, that's the affordable and reliable energy component of that and that's what we did it. The United States built on coal, so did England and Germany, and China is and continues to, and Vietnam. So you can't say don't do that unless you have options that are equally reliable and affordable. And in doing that, then you address the piece that you and I care a lot about, which is helping people lift themselves from poverty.
Yeah, most people. I mean, it's most people in the world who are living in these situations.
Correct. Yeah, the numbers are really, again, staggering. There's about 520 million of us in the United States and Western Europe combined, not Eastern, but Western. That's less than 7% of the world's population. So there are 93%, 7 point something billion, live in various states from nothing to quite a bit. And they're going to continue to grow and evolve and emerge and develop and industrialize. And so how does that happen? It really matters, that conversation. It has to be something that works for them. Yeah. And if it does, they, again, will be able to afford other things like environmental cleanup, in addition to lifting their people up. So I think those are very valid things, the whole poverty and climate piece, but I broaden climate even to land and air and water, because so many people die each year from dysentery. Okay, drinking water that causes them to have diarrhea in poor nations, and kids are dying of it. And you shake your head and go, no, that can't be true today. It's completely true today. And malaria and other kinds of diseases, a tooth infection that wouldn't kill us. But when we switch on, you see us filming in Gunchukwa, Colombia, right on the Venezuelan border for a week, putting in First Solar, a PV microgrid. And half of their kids die before they reach adulthood from things that don't kill us. And so until we begin to address some of that, front of mind is not going to be climate change to them.
I'm frankly amazed by how tolerant leaders are in countries that have these sorts of problems. When I show up, or used to show up, talking about climate change as my leading item, I don't do that anymore, right? As my experience has grown. I think a really cool thing that you're doing with Switch and the Switch Alliance, which is the NGO that you run, or the nonprofit, is to engage young people who live in these countries, university students, say in northern India or in Algeria or in other parts of the world that are not rich parts of the world, in solving the energy transitions of poorer countries, even poorer countries, or at least other poorer countries. And it's really interesting to see how they're coming at it. I had the pleasure of joining the competition and judging. Yeah.
Well, I want to thank you for that. It was remarkable for a first out of the chute. We had 150 teams complete, 260 register from 37 countries on all 6 inhabited continents for the international case competition. And it was on energy poverty. And you saw those. I appreciate you judging the finals, and the Congo and Papua New Guinea. And they're trying to figure it out in a practical way. And then we literally had teams withdrawing. I just pulled an article out of The Economist last week, so I know it was happening. In Nigeria, they say we can't continue because we students were doing a protest and our own police began shooting at us, and the bullets are coming through my windows right now.
Yeah.
And I have the article that just says the bullets were coming through the windows right now. So the effects of energy poverty were playing out with these kids who are trying to do study on energy poverty. And we saw other teams withdraw who couldn't keep electricity going for more than 10 or 20 minutes. So there's no way they could complete the capture of a short film that would allow it to be judged, et cetera. So yeah, the switch is, we're truly an international org, and we're trying to engage the people in it who are living it. And that way the solutions may actually be something that are usable, we can address, and that will move forward rather than the perfect, which is kind of hard to determine if you're not part of that economy or that market or that system.
Well, that's an exercise I hope people who may listen to this will pay attention to and maybe check out on your site. And I hope it grows next year, because it seemed to me, a step in the right direction of creating a much more empathetic exchange between developed countries and developing countries and developing countries and developing countries, to see this kind of thing happening. I think one of the more interesting ones was you had a number of teams from Texas, I guess guys from UT where you are on it, and one of them was advocating that forget about everything else. What they really need to do is develop the oil and gas sector so that they can generate some wealth and begin to develop some proper infrastructure in this country. And they didn't win, but it was a really interesting take on this problem.
Yeah.
And not a ridiculous one.
Not at all.
But a Texan one.
Very Texan. But not ridiculous at all. In fact, if you look at oil and gas and coal globally, a lot of countries are still going that direction. And they will, Rob. We did it, again, because of the efficiency, the energy density. Power density matters, and it's not a complicated concept really, but most people don't know about it. The energy per unit volume or per unit weight or per unit area, however you want to look at it, it matters.
Yeah.
Because that says how much work you can get done with something ever smaller. And if it's not very dense, you need a lot of stuff to get useful work done.
Hard to get an airplane off the ground with flashlight batteries.
Well, yes. Well, and it takes 7,100 of them just to move a single car. And most people don't know a Tesla S has 7,100 batteries. It's bigger than your cell phone, each one in one car. When I ask people how many batteries you're going to have to make to electrify half the world's vehicle fleet, well, first of all, how many vehicles are there? We're about 1.2 billion in the world today. Okay, half would be 600 million. Now let's electrify them. Oh, 600 million batteries. No, not battery packs. Batteries, bigger than your cell phone. Let's multiply 600,000 times 5,000. That's 3 trillion.
And start replacing them every 3 years.
and every 10 to 12 years, you're replacing them. And so it's not renewable, arguably whether it's sustainable, because it's all mining. And 3 trillion, I just, for grins, they're 3 inches long and they're 1 inch in diameter. They're cylindrical, those batteries. They sit in the floorboard and up the walls. And I just started covering a U.S. football field, end zones included in them. Wall to wall, end to end, no space. It took 2.7 million lithium-ion batteries, cylindrical, out of a Tesla in this case, an inch tall. And then I started stacking them an inch layer at a time to see how high we would have to go to get to 3 trillion. 30 kilometers.
I see.
Okay, so past up to where weather balloons fly, past spy planes, and
right,
and a solid stack for 10 years, and then you do it again. And this is just math. It's really simple. That's actually not math. It's arithmetic. And I'm not against the motor. It's a very efficient thing, more than the combustion engine, but the fuel isn't very efficient compared to gasoline.
Yeah.
So gasoline is dense and the combustion engine not so great.
Am I hearing hydrogen coming out of a Texan?
I'm hearing fuel cells. I've always liked fuel cells. In fact, politically, George W. Bush pushed a lot into the fuel cell in his presidency. Yeah. And then it went away under Obama and it stayed away under Trump. But fuel cells are an important option. And I love the idea of combustion engines. electric vehicles and fuel cells, options for different uses. Again, it matters. Portfolios matter. And we get all enamored with one thing. And if anybody says something else, you think they're somehow, often in the deep end. But you just said, well, oil and gas isn't a bad idea. Of course, it's not a bad idea. It's what the modern world has built itself on, is dense energy. Now, I'd like to see more gas. Gas is hydrogen. It's CH4, one carbon, four hydrogens, the methane molecule. So you got these four hydrogens over here in every methane molecule as compared to a lot more carbons in oil and all carbon in coal. So fossil fuels aren't created equal. There's coal and then complex hydrocarbons and hydrogen stuff. And I'm kind of a fan of going into that hydrogen world. I think it has a lot of upside to it.
Well, I'm certainly with you in thinking that hydrogen becomes a bridge from the commonly touted bridge fuel and natural gas to something else. I mean, if we begin using hydrogen in quantities that is produced in this brown mode from steam methane reforming of natural gas, then we begin to develop the infrastructure of hydrogen that would make it more economic for blue and green hydrogen. People are familiar with those terms. We can talk more about those in the future, and really begin to pave the way for a hydrogen economy.
Right.
I mean, it's an enormous advantage that the United States has as a massive natural gas producer to be able to go in that direction.
It is. I think to national security. I mean, I think the other part of batteries besides impact that's so important to recognize is we're kind of moving from OPEC controlling liquids to China controlling mined resources. China controls 60% of the world's lithium, 70% of the world's cobalt, 15% of the world's nickel, but growing a lot of the polysilicon. So the fuel for electric vehicles is controlled by China instead of OPEC. Well, is that secure? And then there's the whole conflict of mining for that in Africa and China. It's not exactly human rights protective when it comes to kids in those mines, et cetera. This is not trivial stuff. And we really need to think hard about where we're moving. With hydrogen, we have that resource. Okay, we do. And we being the United States and North America, but the world does as well.
We have the sort of interim resource, but I mean, it's a ubiquitous resource.
It's a ubiquitous
with renewable energy.
Yeah, we haven't even talked about hydrates, and because they're way off the economic scale at this point in time. But if you start thinking about clathrates or hydrates, frozen methane, locked up, or not methane, but locked up in ice.
There's more methane in the world in that form than in any other.
Oh yeah, it's unbelievable. So I think this is a very important conversation that we need to have for climate as well as for security and cost and other kinds of things. It really does matter what we think about as we march off into that future. Building bridges is a neat concept, but we're always building bridges. In fact, we built really big bridges in the 70s. It's called uranium and thorium. We built nuclear power plants. So we all got sort of unexplainably concerned about radiation somehow.
I think we mishandled it as a society, perhaps as a government or a regulatory regime.
Educationally,
we portrayed it badly. We I think somehow entered a regime in which the regulator, the federal agency is responsible for it, failed to win the hearts and minds of the American public. And I don't know, right. Perhaps that's a regulatory capture phenomenon that happens in very sophisticated industries like the nuclear industry, to some extent the aviation industry. But somehow we ended up there. And I think that's a big barrier to reinvigorating our nuclear industry, really, no matter how safe we may make reactors, which is a real shame.
Yeah. I just finished that chapter in Mike Schellenberger's new book last night on nuclear, and him explaining his perspective on the lack of communication and how, candidly, some pretty powerful, well-funded voices got behind the anti-nuclear game without regard to facts
right.
and played on emotions and showed hundreds of people dying, and Ralph Nader made his name and blah, blah, blah. Yet, China's building 50 gigs of new nuclear right now and has another 100 gigs on the books. I think India should think about it. Very dense economies have to have dense energy, and there's no emissions, etc. So again, fit for purpose, not for everyone. Small modular reactors, 50 megawatts, 100 megawatts makes sense in some places. And so it's nice to think about different things. And then the next generation technologies are much more inherently safe, and their waste is, they use more of their own nuclear waste is in the process, recycle and reuse it inherently. And then, so the volumes are lower, they aren't as hot.
Yeah. We've got some public relations work to do, though, and I mean, it sounds ridiculous to say that, but yeah, I mean but you're right. I mean, there are some exciting options, I would say, even out there in small modular reactors as well as nuclear batteries that could be game changing.
It's a piece of the pie, and all of these things there are no big silver bullets that way, I think, as you come to those conclusions. But if I've got let's say 100,000 people living in some relatively rural area in villages and maybe a cluster, I could put a 100 megawatt small modular reactor there, have baseload clean electricity, and back it up with allow it to back up some other things. It's not a bad solution, because I don't have to build pipelines or roads or wires. It could be literally microgrids of a different scale.
Right. Well, and you could be producing hydrogen even from your nuclear reactors. You could be
producing hydrogen for transportation.
Another big topic. Mm-hmm. Scott, I'd like to thank you for a really interesting and inspiring conversation, a hopeful one for me.
Yeah,
knowing that there's another team out there with similar thoughts.
It's my privilege, Rob. I really enjoyed the visit as always, and appreciate all you guys are doing at MIT, and look forward to working together as we head out into this new energy future.
I'll see you out there somewhere. Thanks.
All right. You take care.